So, first thing I want to talk to you is I want to talk to you about concept of an agentic workflow versus thing you hear everywhere, which is basically called a one-shot approach. What you see everywhere, especially at the beginning when generative models came into bigger view, and you got the first news outlets speaking about the abilities of AI. You see this kind of like clickbaity one-shot example where somebody writes up a prompt what to generate, it to an LLM to generate it, and then either the LLM generates it and it works and everybody says, yeah, that's so great, or it doesn't work, and then everybody says, oh, this LLM is bad or it can't work. So this is what you see a lot. So the one-shot approach has a big issue. It's not realistic, even though LLMs are really good, and even though they can sometimes produce amazingly well thought through and working code. And a one-shot approach, meaning setting up one prompt, giving it to a large language model, having it predict an output based on its weights, which were trained once. Whatever context you give it, just takes you so far. So what I rather like to think of when I use AI or generative models is more, I like to think rather of it like a peer programming approach. So imagine you got a senior engineer, knows a lot of things, is also a bit crazy and stubborn, and really doesn't know anything about your project. Now you take this engineer, sit together at the table, and you start to work together on an issue. It's kind of like the mindset I would like to look at. Now imagine this engineer sits somewhere remote, and the only thing you have is a chat box, and the only thing you want to do is send this engineer one message and then hope to get the whole project working. There are examples which are amazing, but it's probably not the approach that makes you happy. So what you want to do is basically you want to have a conversation back and forth with this engineer, and you even want to have this engineer be able to look up things and try out things. Make an assumption and test the assumption, and then propose an even better solution. So this is what I mean with this agentic workflow in the case what I'm talking about, is basically say we sit together we sit at an environment, we have code, we have commands, we have some other toolings, and I have a conversation back and forth with my large language model. But the large language model has the ability to change things in my code, look up things in my code, execute things, build things, connect APIs, look up something in the database, look up something that's running in the Kubernetes cluster. Exactly. This is basically what I recommend. So now what setup will we use now for the demo, because most of the talk will be demo. It works like this. Just give me a second. That's probably better. So we do a lot of courses, and therefore we need a lot of environments for different kind of courses, which spin up very quickly and have quite a extensive requirement for all kind of tooling, depending on the course. That can be Kafka, Argo CD, Elastic, Prometheus, whatever you name it. Most of the time you have a Kubernetes with it, you need some Docker to build images, you need everything authenticated, you need a Git project, you need GitLab CI or whatever other tooling you need to do the course. And this setup we call a lab machine. It's basically a crazily overloaded, over-engineered dev container. So what this means is we have a container running on on hardware somewhere, which spins up And we connect either through Code Server, Visual Studio Code, thanks to Microsoft, by the way. It's one of the best pieces of software, I think. I also like to use Vim, but otherwise VS Code is really nice. So Code Server through the browser, or we can directly connect to our dev container lab machine through our local Code Server, Visual Studio Code. Now, in this VS Code, I like to use an extension which is called Cline. Cline is an extension which is open source, so I also wrote some little addition and patches to optimize my workflow, which basically enables me to do this kind of like agentic engineering workflow. There are many other solutions. They're like obviously GitHub Copilot, which is amazing for certain cases. And there is a separate cursor AI and all those kind of things. But for me, Cline won the game for my workflow. And you will see later on why it's the case. It's probably not the best choice for everybody, but it's the best choice for what we are doing. Or so far, maybe it changes in 3 weeks. And we are using something called Open Router, which basically allows us to choose between a wide variety of models and having one point of entry for API calls and managing tokens and managing budget limits and choosing whatever newest model we think fits best. At the moment, we're mostly using Claude 3.7, which I think just was published 3 days ago. Yeah, exactly. Claude 3.7 Sonnet. I actually also really like to use Gemini 2 Flash. I will talk about that later. Now, why is this interesting with this dev container approach? The interesting part is this. Overall, if you are engineering software, or also if you do DevOps engineering or platform engineering, it's usually a hassle to kind of like get this tooling and configurations right for everybody. So probably a few of you, who of you already used something like dev containers? Okay. So the idea is basically you have a container which contains all the tools and configurations and versions, or can get the configurations injected and have all the tooling and versions you require to work on a specific project. And now, instead of basically installing this tooling on your local laptop, when you work on a software project or also a GitOps platform engineering or whatever project, you spin up a container, either locally or remote. And now most modern IDEs or many IDEs like IntelliJ or VS Code, actually it's wrong to say many. Because it's IntelliJ, VS Code. Yeah, I'm sorry. That's absolutely true. There is some other solution which I think is a bit is more like ID agnostic, but it basically allows you to run to work with either VS Code or IntelliJ inside this container as if you would work locally. So you can work with Git, you can run commands, you can edit your files, you can set breakpoints and all those things, but it's always running in this container exactly matching your project. Now, this is even more interesting as soon as you let your AI model do stuff on your environment. That's the point where you should say, if I let a model, large language model, run commands on my machine, probably I want to put it at least in the container. Okay, so what I want to do now is I want to take you on a very risky journey of taking an app that I actually also completely built with this agentic approach. It's an app which has a front end. It's a client-side JavaScript front-end single-page application. It has a back-end REST API, and what it basically does, it allows you to generate diagrams, mermaid diagrams, based on a prompt. That's just something I built. It took me actually about 1.5 hours to build it, and you will see. But that's not the focus. The application itself is not the focus. I just needed a pet application. And what we want to do is basically we want to containerize it. We want to orchestrate it on a Kubernetes cluster, and then we want to build a CI/CD pipeline for it. And we don't want to do anything ourselves with coding, actually. Exactly. Let's see if that works. So may the LLM have mercy with me, because as you probably know, large language models predict things based on their weights. and they also predict things differently for the same request. So it's not really, how is the English word called for it?
It's non-deterministic.
It's non-deterministic, which can be interesting and fun, but it can also be very painful. So let's see. I don't see my mouse. Okay. So for now, I will just show you the application so we can kind of look at it. That's not a big deal.
Can you zoom in a bit?
Oh yeah, good point. Oh. Usually I start a local VS Code and then I basically use a remote to basically do dev container. Now I started our code server in the web browser because of the because it works a bit better with the what do you call it? From here to the server I'm running it on. So okay. Let's see. Just run this application. And then I will, it's one of our handy tools to generate an entry point. Let's see if that works. So that's the application. Any topic you're interested in? Anybody, any shout out?
Mermaid diagrams.
Okay, but what kind of diagrams?
Cluster architecture.
A native architecture. Let's see. What happens now is basically the browser sends this text to a backend, which Claude wrote for me in Go. This backend takes the prompt and sends it alongside something we call system prompt, fancy word for putting strings together and hoping the large language model does something better. So basically, there is a prompt text before my prompt. So this text is my prompt, and there is another text which basically says gives the model some more information of how to act. Does this make sense, more or less?
Accurate. Mostly, just needs a few more arrows.
Okay, perfect. So this is just a very simple example. If you look at the code, it's a lot. It's not a lot. It's really pretty simple. And there are basically a lot of services and apps which are basically just like that. They wrap some large language model with some additional prompt or some additional information, and then give you a better result right away than if you want to do it yourself. So, but that's not interesting for what we want to do now. What I want to do now is I want to get this containerized and I want to deploy it. And I want to automate that because it's DevSecOps. Sec, I have to scan the image at the end. I forgot that. Okay, but yeah, I hope I did a cleanup. So let's go. Now there is an even cooler thing, agentic workflow or agentic engineering. There is also something called vibe coding. I don't know if you know vibe coding. It's the newest thing. So let's see if that works. Okay, so I'm a bit nervous, so I have to kind of like cheat. Okay, so containerize the backend in this project, build an image, push it to the registry of this project, and then run the backend container. Okay, let's see what it does. Now, Cline is a open source VS Code extension, and it's basically this chat window, and it has the ability to edit files, run commands, and now also to basically call other services to get more information using something called model context protocol, which I'm, based on timing, maybe be able to talk about. So now it will read files, and I gave it the ability, because we're in a dev container, to basically read files and run trustworthy commands without asking me. So you can basically tell it to either either ask you for everything or just do things right away. So you can configure whatever what points you want to be able to interfere with what it does. So you see here what it's doing. It basically got my prompt up here. It started to make a plan. It started to look into this folder. It decided, maybe I should look into that. Maybe I should look into that to get some more information, get some context. So I didn't have to think what context I have to give it. It looked at the configuration, and then it felt confident. Hey, let me write this Docker file. I will not let it automatically edit files and store them, because this is always a great breakpoint for us to basically review what it does in the files. And that's also something I recommend to you. You could also let it run completely on basically autopilot. So it would just edit files and then test it and whatever. But I think as soon as it's editing a file, it's a good thing to basically look at what it did. So what it did here, it chose an image version for a build step. So it's a multi-stage build, and then it chose an image for the what's delivered at the end, and it copies basically the artifact from the build step over. We could also tell it now, maybe look up the actual current version or latest version of this image. So the large language model has something called a cutoff date, which basically means the information used to train the model, if it's just the model without any other like connection to search engines. And that means it has a certain information about the version. So if I would want to know that there is a newer version, and the whatever model I use doesn't know of that version yet, I could tell it now to look up the version. But I will do examples like this later on. So that looks good to me. And that's an important advice to you. Whenever the model does something for you, you should feel confident to validate what it's doing. That's an important thing. Less confident you are about knowing what it's doing or what it's up to, the more pain you will feel, or the more you will struggle, and the smaller steps you will have, and the more you will have to get an explanation from the model about what it's doing. But that's like everywhere in tech. If I take whatever, if I want to build a Rust kernel module, which I would like to do, but I can't, and I would just go on Stack Overflow, copy paste some examples, and then just replace some strings. It's the same thing. So if you start with something you don't know yet, you have to take smaller steps and look into it more and validate what it's doing to understand it. And it's the same with large language model. It's just that the large language models give you a more customized version of what you think you need. Okay, so what did it do? It built the container. It and the container, and it if the container is working, and it sent a request to it to check if the backend responded correctly. So now you see there is actually an error that the prompt wasn't properly formatted here. So the model got this command wrong, but it will probably still work. Give me just this over here. Try to, again, testing it with curl. I wanted to first test it with curl, and meanwhile, I can also show you that the image is now built. Let's look at this container registry. So here, at the back end, second. They already exist. Oh yeah, of course. I didn't change anything. That's my pity. Let's just change something. Or let's just do the next point with front end, and then we'll for sure have a change. I basically told it to correct, and that's what I mean with this interaction. So it did things. I'm verifying what it's doing. I saw it missed something, and I tell it now to try again, giving it the error. Usually it catches the error, and then basically sees, okay, I have to correct, but for some reason it didn't catch this output or it didn't realize this error. As some peer programming engineer would maybe also do. So now let's do the same thing for the front end. Now containerize the front end using an Nginx image. Make sure you don't forget about the backend URL txt, and build it, push it, and run it. I won't let the model speak back to us. That would be really annoying. I tried to do that in a cube capture course when in a cube capture talk, and it's a mess because it's not audible. It says too much, and I can't filter out if it says something. I want to say stupid, but I should say something else. If it says something I don't want it to say, so I rather have this and then read it to you whenever I like to read it to you. So now it built this second image, and it did this. So I confused it actually. I told it to write this into it, but that's actually not really helpful because the URL will be different. So remember, you're running in a lab machine, so double check on the URL and check if the current file is actually already okay. Because we won't let it run in localhost. I want to say, oh, that's later on. Sorry. Okay. Perfect. So I thought it has to do something because of this backend URL, which I use so the front end finds the backend. But that's not the point. It has to do it. But I catched it because I saw, okay, localhost 8080 doesn't make any sense here in this context. So now I fixed it. So that's what I also mean. That was obviously on purpose. No, that's also what I mean with knowing what it's doing and being able to verify it. By the way, one thing I like about Cline is it's showing me the amount of token it's using. It's showing me the cost the cost impact I have, and I only pay for the tokens depending on the model I use. So I could choose a cheaper model. I could choose a faster model. I could even try run a local model, which I wanted to do for the talk, but the quality is. This machine, the models I can run on this machine, the quality is so much lower than the models I can get through the API that it's just not worth it showing you some smaller model trying to use this tooling with Cline. Doesn't mean that local models don't work at all. It's just the complexity of kind of like having this tooling is out of reach for those models. If you use a solution with a monthly subscription where you basically have the model included in the solution, obviously the provider of this solution has an interest for you to use less tokens and to optimize the token usage because you pay a monthly fee independent of how much you use depending on the solution. I rather choose my own model and then can choose if a task is worth it to me to create that cost. Let's see what it's doing here. You saw it made mistakes, by the way. It used the Docker parameter, which doesn't exist, and it fixed it itself. It also checked if it's working. And now let's see if this works. So now this is a bit of a bad demo because in reload. So this is actually now running in a container. We can basically quickly test it. Docker PS. Go stop. Where is it? Mermaid front end. See if this is really in a container. Yes. And you see, this is something I won't tell the model to do because time it takes to basically run this command is much longer than if I just write it myself. There are many more cases, obviously, similar to this. So now we got this running in Docker containers. Now what we want to do is we want to basically orchestrate it. So I want to basically tell it, write a Kubernetes orchestration in a folder called K8s. Write manifests for front-end and back-end. Write a manifest for ingress and all other resources needed for this specific application. To get an idea how ingress works on this cluster, look at existing ingress, other namespaces. Please use the default namespace. By the way, the tool I use for text to for the speech to text is called where is it? It's called Whisper. It's just a Mac tool that allows you to write to text to speech with the OpenAI Whisper model. I work for myself mostly. I'm just typing, but for the talk, it looks a bit cooler if I. It's really good. So it's really crazy how good it is at understanding my sometimes broken English with using the wrong words, and also especially kind of like having something like technical words converted from speech to text. I mean, if you use, for example, something like Siri or Apple speech to text, and you say any technical word, it's really hard. You know what I'm talking about. Okay, let's go. So we basically create something, a backend secret. So that's already pretty good. There is obviously an error in there. Let's see if it catches it on its own. So then there is a backend deployment it will be writing. Last time it didn't think about the secret at first. This time it did the secret in the first run, but it got it wrong. Did anybody catch the error? Catch the error? Yes, exactly. It will not be able to basically using a bash variable will not be possible in this secret. So there is an environment variable with this token, and I told Cline using the Cline rules file that these variables exist. So there is a file called .cline rules where you basically can add nodes and information for Cline for a specific project to adhere to certain structure, to certain rules, and also to know specific things about your environment and project. And most of the things, it's just fancy text concatenation. It sounds cool, but it's basically taking a little bit text from here, looking at the file list from here, taking a little bit text out of this file, putting everything together, sending it to the model, analyzing the text from the model, and trying to figure out what it wants to do. Yeah.
Good question.
Yes.
So you said, well, you asked it to look at your current ingress that you've got defined in the cluster.
Yeah. It will do this. Did it already do it?
How does it connect to the cluster? Does it just use your local kubeconfig?
I'm using at the moment, I'm just using the command line. So the model is allowed to run commands. It's allowed to start browsers and steer browsers. It can click around. We'll see that later on. And it's allowed to read and write files in the project. So there is something called MCP servers, which is a model context protocol, which is it's mostly JSON protocol, which comes from Anthropic, which is about mostly it's about wrapping services in a way that the language model has an easier time using it. I'm not using that at the moment. At the moment, I'm just using the Cline internal feature that it can run commands. And as you will see later on, as you know, if you're in DevOps, you can do nearly everything with commands. So it can actually do nearly everything I want it to do. Let's see.
How do you stop it from doing something stupid on your cluster?
You shouldn't run it on production. That's why I run it in a lab environment. So this cluster, if I kill the lab machine, the cluster is gone. If I start it again, the cluster is up again. So obviously that's an important thing. If you want to go full on, let it do a lot of things. You have to for sure be able to verify what it's doing, and you have to for sure have it being able to test things on an environment where it shouldn't be able to mess up things. And so it recognized this pattern. And now let's see how it solves this time. Sometimes it calls it Mermaid backend, sometimes it calls it just backend, and sometimes it calls it front end. So it's always a little bit different. Now, see what will happen. We applied it to the cluster. It's, by the way, a bit slower than usual because I'm going going over to Europe. Oh, now let's see if that works. Please use your browser to verify if it's working. See if that's nice. That's the app. Looks nice. Something wrong. It's actually working. Oh, that will not work. Okay, so instead of changing ingress, which will not work in this case, you should think about changing backend URL txt in the front-end container with a smart way, usually used for things like this in Kubernetes. I wanted to learn something. It's, by the way, per definition wrong. A model doesn't learn while using it, at least the regular model we are using. And that's a misconception that often happens. The reason why it feels that those models learn is only if you use the same model, the same weights, and you send the same thing. It will not learn from a previous request as long as there is not something left over which was handed in again. So the feeling why you sometimes think those models learn is because there is some additional string of text that was just handed in with your prompt. Obviously, models are retrained. Models can be, what is the name again, when you train it? Fine-tuned to a specific case. But if a model if the weights are loaded for inference, it will not learn, at least with the algorithms the way we mostly use it. The reason why we think it learns is because your tool, like this Cline, which is, by the way, if you look at it, it's not that fancy, stores some information in some text file in some database and just gives it along with your prompt, and then it feels to you like it's learning.
So does it learn, in quotes, for the length of your context window? Say, or like, I mean, can it go back? Like, how far back in your context window that can it actually go?
So this model I'm currently using has 200,000 tokens I can hand in. If I go for Gemini, I could use 1 million token, which is a lot. So if you have 1 million token, you can throw in like huge code bases, which doesn't mean that it actually has attention and has the ability to actually do something useful with 1 million tokens. So if you take a huge project and you just throw it at Gemini, it will still give you some crazy effects because the model is still not capable to necessarily give you a much better result with more context. So sometimes less context can be even better, because the model sometimes has a hard time if context you give it is actually meaning that you want it like this. So if you have some code in your project which isn't good, and you give it in as a context, the model will maybe think, oh, that's the way you want it, and then we'll just reproduce the same error in a different component. So it's so selecting the context can also be of an advantage. So I didn't do this here now a lot. I can also select which files I want to use. So what Cline does is basically it gives it instructions of how to work with Cline, and it gives it some information about the whole project with like a file structure and some additional information. And then the model has the ability to ask for more information if the model thinks it's helpful. But I can, on purpose, I can actually go here. I told it shouldn't never do more than 10 steps without asking back. If I have the chat window here, by the way, I could go here and basically give it more context manually. So I could give it terminal output. I could give it problems from files like some linting error or some other error from which the IDE had, some Git information, folder structures, files, and so folder contents, and so on. So let's see what's happening. Look on the time. So give me a second. I will just get ingress myself. Not sure if it applied it. I was talking too much. Looks like how to fine-tune for tool usage. So exactly, that's the other error, which is basically fix the secret because you use a bash variable which doesn't work. One thing you should really know about a language model is often the language model always wants to serve you vanilla ice cream, which means the following. Most models will be trained on content that's most commonly available out there. I know I could use sealed secrets or vault, but I didn't do it on purpose. I could tell it how to do it, but I didn't. So what that means is this. If you don't give the model more information, it will usually go back to the default, to the most common case it knows from its own data. And that's one of the most frustrating things usually is that it's trying to do this basic tutorial kind of thing, but you're actually in a production ready project and you wanted to do something specific. And you think about an engineer joining your organization, it's kind of a similar thing. What do you want an engineer joining your project to have? Some guidelines, how to do things, some example projects to look how it's already done. So this is kind of something you will want to look into. Basically, give it an example of how to do something. For example, don't let it write a Helm chart from zero. Even the best large language models will really struggle to write a nice Helm chart. So give it a nice Helm chart and then basically ask it specific things to change towards the project you want it used for. Okay, so how to fine-tune a model for tool usage. Let's see. Long. Okay. Probably didn't wait for it to applied. No. And that's on the cluster now. Hope I didn't mess it up again. Did I accept it? It was working. Ah! Okay. Okay. I'm doing too much, of course. I'm doing more than that I can really like reasonably capture. So let's go back. But it's working. So now let's go really bold. This is typical things to fix. Okay, now I can start a new session and will basically lose the tokens, or will not lose. I will just not stop sending all the conversation we already had back and forth. So what I did now is a really long conversation without starting it again. So the model, Cline. So Cline sent all the output, all the changes from the whole conversation back and forth to the model. That's why it's already costing me $1. If I go and start a new conversation, I can be more selective and tell it, look, tell it like what's useful, probably like the Docker files. Maybe the Kubernetes, the right one. Now maybe go for write a GitLab CI/CD pipeline, add jobs to build and push backend, as well as a job to build and push frontend to the current project using GitLab variables. Also write a GitLab job to apply it to the Kubernetes manifest in the default namespace. Make sure that you adapt the manifest to use the short commit jar you used as an image version tag. Or the GitLab project is already set up to be able to have a kube config for this project, so you can just run kubectl in an image that has kubectl installed in the job, meaning choosing a job image. Is it still interesting, or is it already like, oh? Okay. So what it does now, so maybe you already know I'm cheating. I'm cheating in a way which I think is useful. What I do is I wrote this client rules file and already told it things I wanted to do. So for example, instead of doing the most basic GitLab CI tutorial style pipeline, where you have this global before script and global variables and define the image for all jobs at one point, this kind of like tutorial copy paste pipelines, I already told it, please split my pipeline in useful components, include them in a pipeline, and keep the configuration of a job within one job. So I already gave it a lot of useful information in this client rules file. Doesn't mean it doesn't do mistakes, doesn't mean that it doesn't do things the way I wouldn't do it. There for sure is always things I would like it to improve. And if I find something that I think it should do better all the time, I would just write it into my client rules as a statement, and then basically it will hopefully do this better the next time. Let's see. That basically how it's finished. You can also, by the way, tell it to to do something at the end of each task. If you want to have it, for example, do a git commit or do a verify or run a test or whatever you want it to do. Like you can tell it always run the unit tests at the end. So what I will do now is I will just say follow. Do a better commit later on. So let's see. Obviously, this should just continue to run. Maybe we see now different containers. So not necessarily because we change anything. Let's see. Okay, wow, worked. I thought I saw some things which I'm not completely happy with it, but obviously usually I would go through the files before saving it. So now did it actually deploy? Let's see. Did it actually deploy? Can you check the versions of the images? Oh, I'm over time, I know. Now it's doing something I wouldn't want it to do. I don't want to actually validate it now here. I don't want to make this more complex, actually. I want to just do the following thing. Run a kubectl command in the command line to quickly show me the versions of the images. That's questionable. I just could also go like get replica set. So, yeah, but it did actually deploy. Do you see? 415, let's see. 1.5, so it did deploy. But we could actually do better. One more thing, one more magic trick, and then I will finish. So let's just say we're really lazy and even want to read what's to do. That's really strongly made up example. Imagine your product owner just adds issues. Update Kubernetes cluster. Go for it. No, don't do that. Okay, let's see. Solve an open GitLab issue and do a conventional commit. Let's see how that works. So I gave it some hints in Cline rule how to basically fetch issues from my project. I could use the MCP server, but when I set this whole thing up, there were no MCP integration model context protocols integration in Cline yet. So I basically made my own MCP server using scripts and just telling it, hey, you can do this with that script, you can do this with that script. And at the end, it's just throwing strings around. And Cline hopes to find a string from the large language model, which tells it to run a command. So you see what I actually wanted to do is I wanted to add the commit version here. And I put this in an issue here. So it basically has the ability to fetch issues. There is a bit of a nicer way. You could use the GitLab client, you could use the GitLab MCP server. It directly does an API call without going through the terminal. So now it does this commit, git add, feed frontend, inject, commit char to index HTML, blah, 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 closes to. If we would have more time, we could also look at the MCP servers. That's something you can look into if you use one of these tools. That's interesting. So we could integrate something like Perplexity. If we want to, does anybody know Perplexity? It's kind of like a LLM wrapped search engine. So it basically gives you answers with very up-to-date information, which is not always helpful. Like going to Google, copy-pasting the first 3 pages and hoping that it's right, but it's helpful. So long story short, if the pipeline goes through, be through. Tell it to push, it won't push. So that concludes my demo. I'm waiting to tell it. At a Trivi scan job. Now let's do that, and to be deployed, and then we will see the git commit char here, which I did in the issue. So patient, it work. Yes. Isn't it nice? And now let's see. And the issue is closed. My Cline rules file is like this. Okay, so is there any management going to your engineers next week and telling, I saw it works, he's doing it like this? Just obviously that's kind of like artificial example. Okay, let's go back and sum it up.
Don't forget to commit and push. Don't forget to commit and push.
Yeah, exactly. Like exactly. Let's go. Oh, we containerized it, we orchestrated it, and we did a CI/CD pipeline. So the most important thing I think for you to find out is kind of like the productivity zone. And that's very different for everybody. It's based on your preferences, it's based on your knowledge, and it's based on the complexity of the task and the project. And it's also based on the verifiability. The harder it is to verify something quickly, the more annoying a lot of generative AI output can be. So the things that work best is things that you can easily verify after the AI model does it. And also, obviously, something like rarity. Obviously, this is just painting. This is nothing statistical. That's just making it look more interesting. And also something like rarity, of course, like if you have a system, if you work on a system which is rare, which is something not known to the public, the models were not able to train on it, and obviously it's probably much harder to get something useful. So what I recommend you is to start with something that integrates in your environment. And it's kind of like training yourself, exercising to use them, and finding this productivity zone where it actually helps you. And sometimes you try out something and it doesn't make any sense, then you put it away for 1 week, and then 1 week later you have another example where it maybe fits again. So that's it. Thank you very much. By the way, we're also in New Zealand. Caleb will do a course on Monday. We have about Kubernetes, and we already have 4 or 5. No, we have 4 or 5 participants. But if anybody is interested in the course, just talk to us later. Thank you. Then I hand over to.
Thank you, Jonas. We're going to have a quick break. So we will do a bathroom break, have a little drink, and we'll get back here in about 10-15 minutes for Caleb's talk.
Koto, my name is Caleb, and I'll be taking this next session. And today I want to talk to you about secure software supply chain, and specifically talking about Sigstore. Who's already heard of Sigstore? People? Let's make that maybe 30. So yes, today we're going to be going through these particular things. So we're going to be talking about what is software supply chain security, what is Sigstore. We're going to be talking about how you can upgrade your CI/CD to integrate tooling. We're going to also talk about how you can trust workloads, runtimes, and also with Kubernetes, and how you can give it a go. Everyone's think that's all good? So this is me. I live in that place in the other part of the North Island. I think it's better, but you all live here, so that's your problem. Yep, I like software and infrastructure. We're here, surprise. Some stuff I've done in the past includes I've helped our local internet filtering company on their WRT routers and infrastructure. I've also been a part of the Kubernetes project in two areas, namely the Conformance project and Cicade's Infra. I've also done some cloud stuff and some other fun projects along the way. Yep, very welcome. So let's start by talking about software supply chain. So you have this. It will look something like this. You've got your tool chain. Your tool chain depends on something. You're using a dependency from that tool chain. You've got your product. And this is where, oh yeah, I forgot about this. This is fun. So the best part, running a command called caffeinate. Cool. Great. So we're not working. We are working. Okay. Cool. Everyone think this is pretty familiar? No questions. Cool. Not using something that's yeah, so our industry does in fact have a problem. So that's all good. We've had a few big attacks over the past few years, and these have been various levels of catastrophic in various capacities and people attacking in different ways. You've got a few things like someone, instead of typing the name of the package, they like missed a letter out or they put a double letter or something. Or maybe someone's just like slipped in some malicious code directly into the project. Or maybe their automated systems for building are just like messed up. I don't know, not good. So first about trust. Who run a lot of code written by a lot of people who all share stuff, and that's all cool. But trust is incredibly important, and the fundamentals of the internet is built on trust. You can think BGP works, like everything about the way that humans interact is about trust. What does software look like? You've got developers developing, surprise. You've got programs and dependencies, they're writing that stuff. You've got the build systems that are making those things happen. You got stuff being continuously deployed, hopefully, and then you've got production clusters. So that's all. That's what we're dealing with, and we got to find ways at each of these steps to support and make sure that people are doing the right stuff. So, question to you: what are your trust levels? Who just killed the bash? One? Was it out? Leave. Okay. I mean, if that's you, then that's all good. Not really, but there's a lot of ways that you can run software. Who just installs a random dependency? The way that you came in is the same way that you go out. Maybe it's just the connection. And then also your CI, do you trust, like, are you using a publicly hosted build infrastructure? Are you self-hosting? Those kinds of things. So my call to action is I want you to be able to discover what your program contains and know how it's built. I want you to be able to enrich the build process with a few things like we'll get into today. And I also want you to know how that you can enforce in your production environments to run the software that you expect to run, what you know is meant to be running. Straightforward. So, without further ado, let's talk about Sigstore. I quite like their very to the point quote of making sure your software is what it claims to be. I think that's cool. Under the Open Secure Software Foundation, or OpenSSF, and they're a brand of the Linux Foundation. And we got a landscape containing a list of projects consuming or being a part of or actually being Sigstore. This is pretty fun. Small landscape, but this is what they've currently got. People have contributed to. This is what the architecture looks like. Cool picture, love diagrams, but you can read the text because that's easier. Transactions that you can publicly audit. You got certificates. So I want a short-lived certificate. Here you go. Now you can sign it. Also, they host the certificate authorities. So you're able to like, hey, I want a certificate from you, and then everybody already trusts it. And then you have a tool that you can do sign, verify, and all that good stuff, which we're going to get into. Trust but verify. Who's heard that phrase before? Yeah, security people, my people. You have a public. Words are really hard. Who even came up with them? Like trust root. And then there's a whole bunch of people across various organizations. So it's not just like Google. It's not just like Microsoft. Although we were really thankful that they would allow us to be in the space today. Appreciate it. And stuff like that. We've got auditable infrastructure. You're able to view how it's deployed. You can see everything that's going on. You can see every single event that happens. So let's say your friends over at Control Plane are signing with Cosign. You can tell me your index, and we can go and take a look at exactly what happened. You can view that in real time, and it's also open source. You can be a part of it. I am, and Cosign. Let's get into this command line utility for interfacing with Sigstore related things. Cosign is one of those tools. It's the big main one, and you can do things that we'll focus on, like sign, attest, verify, and look at all of the things. And it also uses OpenID Connect. Who's familiar with that? Yeah, that's the one. Good stuff. In the right place. So let's take a look at signing an image. So you'll have a command much like this. You're signing recursively, so any sub-images with a key, if you're using key pairs, an image, then it will output the index of which it was put onto the transparency log, and then you can also see where you'll end up finding it. So you want to verify it. You can run the verify command with the public key if you're using key pairs, and then you can see, okay, this image was great. So it is the one that we expect it to be, signed by someone who has the key or such things. Then you can also list artifacts. So for example, this image, this is not my password, so it's okay to put on the screen. And then you've got the signatures and you've got the SBOM. We'll get into that soon as well. And actually help myself out here, but anyways, you have Falsio. So this is the authority for generating these short-lived certificates. So you'll have a new certificate that comes up for signing a given artifact, such as a container or a blob. And then you have Recor, which is that transparency log service, which allows you to see everything that's going on. So you can watch it in literally every way possible. Like you could run Recor CLI log and then watch everything go or whatever you want. Pretty cool. This is the web UI where we've chucked in that same index that you might remember me pointing at just before. And then this is the public key that signed it, and you can view all of the other information on it. If the container image was signed, or if the artifact was signed with OIDC, you'll see like the issuer, you'll see the subject and things like that. It's pretty cool. Speaking of OIDC, we have keyless mode. Here you have those ephemeral keys that are generated for that particular instance that we're going to sign the image, which is pretty cool. This is what a verification looks like for a container image for a project that I maintain. And you can see here, we're checking for the validity if it was signed on GitLab, and then we're checking if it is from main or if it's from a tag. You can see it, we think that the signature is great. And then over here, you can see this chain guard image is built on GitHub, and then we're checking pretty much the same thing. I'll make it pretty simple for the example here, but you can see it's all fine, so that's great. Who knows what a software bill of materials or SBOM is? Thank you. You don't have to leave. You can stay until the end of the talk. So pretty much, your software has things in going on inside of it. It's got heaps of dependencies, and we want to be able to catalog all of that information. It comes in two flavors. Pick one. I personally like SPDX. There's probably other flavors, but all the supermarket had. And so we go with that, and you can think of it like a New Zealand supermarket health label or the ingredients list, whichever you'd prefer to think of it as is the right one. And for instance, on this same project, which I've got software build of materials generated, this is one where it specifies the multiple architectures of the container images. So you can see over here we've got the base image that's at the top layer of the container. Then you've got the AMD64 image in here, and then you've got the ARM64 image in here. And here's also the connections for those things. So you can see, okay, this one goes to here, this one goes to here, and we eventually get kind of like a tree situation happening. And here is for the ARM64 one that we just saw the line highlighting. And what we're going to see here is we've got dependency. This is a Go app, so we've got Gorilla Mux, great HTTP router library. And you can see, oh, this is actually the source where it came from. So that's really handy. So we know what version the package is. We know what package it is. Here's another one. We got Prometheus client. So for example, this app exposes a Prometheus web server for your infrastructure to scrape, where that's there. And then you've got Gorilla Mux being a part of it. And so you can see we've got this is in the depends on. We've got a dependency tree that we're building. What did you just see? That might have been a lot for you. It is a lot of text. So essentially, the things that we care about, what's it called? What version is the syntax of what we're looking at? How is the data created? Could be like a unique identifier for the package. In this case, the SHA-256 was the packages, and then you also got the relationships. And maybe you want to do something with all that data because maybe it's just kind of boring if it's just hanging around there. So maybe we want to generate a graph that looks like this. Who can read this? Anyone at the back? What you're looking at is exactly this. So you've got, what's the group that it belongs to? You've got a base image, the thing that you actually built, and then its dependencies. That's pretty much it. If you were to have that as like a file on your computer and you could zoom, it might be useful, or you maybe tell it to render differently. I don't know. I ran the tool. It gave me that. Thank you. So let's talk about producing an SBOM. There's plenty of ways to do this, such as through Sift. Sift will just give you an SBOM. That's the slide. Also, the Kubernetes project has the BOM utility, which is used in SIG release for generating the bill of materials over there. And I produced the previous one that you just saw with Co, and so you can see Co here will output using the SPDX format, which I prefer there. And if you're in the JavaScript ecosystem, you can use NPM. It just already supports it, so that's great. Like salsa. Yeah. Come on, you're the lame. Now we're talking about this salsa. So salsa is a framework that's like, you can think of it built on top of Sigstore. It's a way to encapsulate. So Sigstore's concern is more about like the artifacts and proving the artifacts, but Salsa's more concerned not only about the artifacts, but also about the build environment. So maybe you're building in public cloud and you want to make sure that things are a bit tighter. Maybe you want to move things along and you want to have like a hosted build platform. That's what Salsa's a part of. And so you can see here, wanting to make claims about the build environment, the dependencies, and the artifacts. You have 3 levels. That's a few levels. So we have the main things that you should like to care about, unless you want to read the rest. I'm not going to immediately change the slide, but you've got basic reproducibility. So if I build it, you can build it. Same matching thing. That's cool. Increase your auditability if you go to level 2, and you have quite like this phrase, confidence and providence. Say that 2 times. That's pretty fun. There's different projects at different levels. These take time. It's not like you can just get to being completely certain about all of your pieces of code and infrastructure in one moment. So it does take a minute. Here's some examples of projects and companies which have adopted Salsa in particular, which therefore have adopted Sigstore. And yeah, look at these ones. They're doing pretty good, level 3. That's nice. So you can absolutely prove that you run, say, Flux CD, shout out to Control Plane, that the thing that you're running on your cluster is completely verified. That's pretty cool. And you can use GitHub Actions for this. Hello, Microsoft. And yeah, here's an example directly out of this link. But yes, you can just use GitHub if you like. GitLab, you can read this article if you're interested. Tecton, which is a Kubernetes native CI, which came out of the Knative project, is great support for Salsa Providence, and you should run this. It's pretty cool. It's pretty cool. So let's take a look at. So that's all cool, but okay, can I use it? I guess let's talk about that. If you're using tools like Cryo, Podman, or Bootsy, you can write a manifest such as this. This is one that was taken from the Bluefin policy for these things. Who's familiar with Bluefin? Universal Blue. Okay, you have a lot to learn. It's gonna be cool. Anyways, you can make sure that for any container image starting with this, it must be signed with this public key. Or sorry, it must be able to be verified with this public key. I've created a repo recently, this one, and it creates a version of Fedora Atomic, which can only run container images signed by my private key. I think that's very useful to be able to do that. So what we're saying, you know how we had that prefix before? We've got an empty prefix. You know what that means? It means that anything, it's like a wildcard. So any container image that's run with either Podman, Cryo, or Kubernetes has to be signed by me. Otherwise, it doesn't run. And that can be really handy. Maybe you're like, you really care about the software that you're trying to run, that it has to be from a proven source. You can do that. Like you don't like it. That's really cool. I'm excited about that, and we're trying to get Knative running on there with Kata containers. Currently stuck up on the Kata containers part, but that will be resolved soon. Then another thing that you can use is policy controller, where this is a Kubernetes validating webhook, and you can make sure that every time it creates a pod, that it will check that pod to make sure it's verified against how you expect it to be. What I just said, and also you can check the SBOM contents. You can say like, a container, if it has this dependency, I don't know, log for shell, we can make sure that doesn't happen. Or log4j preventing log4shell. And for example, here's a policy for anything that's from registry.k8s.io. It has to be signed by the SIG release automation. So that's that. Or if who's using Cert Manager? Yeah, that's the best thing. Don't use anything else. Go home. We got this public key. We're wanting to verify that. And then here's an example. This doesn't fit on my laptop screen, so I like this. Yeah, I built this repo a little while ago, and this is just testing to make sure that it came from main or a tag in a particular regex is cool. Kind of hurts the eyes, but it's cool. I like regex. Maybe you don't want to have specific log4j versions on. We don't allow it. We don't even let your container run. I think that's really cool. Who has this already? No one. You should do this. That might be useful. Kyverno. Who's already using Kyverno? Yeah, okay, we got a few. You can do this stuff with Kyverno as well. So for example, test image right here has to be able to be verified with this public key on the public Sigstore infrastructure. Or maybe you're using Tekton and you want to make sure that an image that's run with Tekton is signed with, is verifiable with this public key. You can do that. Maybe you're using Kubevert and you want to make sure that your container disk image, which is VM QEMU image packed inside of a container tar, then maybe you want to be able to verify that. You can do that. Maybe you're using Flux, which is really cool. I don't know if anyone's using Flux, but you can verify your Helm charts that are distributed and consumed with Flux. Or who's on a Mac or Linux and using Brew? Oh, you're already using all of this stuff, and I think that's really cool. Every single program that you've downloaded since, there's no date stamp, I think it's like a year or two, been verified against Sigstore. That's cool. The software that you're running is proven to be from the CI. That's amazing. I don't think there are any other places that are doing stuff quite like this. So we've covered building, we've covered production. Developers, no. So Microsoft building. So maybe your developers, maybe you care about the stuff that they produce, let's hope. And maybe you want them to not use GPG. I use GPG, I think it's great. Keep using it if you're not using anything else. But maybe you're wanting to verify their commits against using Sigstore. You can do that. This is the magic. No, it's right there. GitSign is what it's called. Go Releaser is a popular utility that's used for releasing Go apps as binaries usually, and let's build them and put them in a zip folder or just upload as they are and all that stuff. You can generate SBOMs and you can also sign the binaries, because we also sign binaries with this stuff. And there you go. That's how you do that. Pretty cool. You can even run it yourself. Amazing. There's several different Helm charts. You'll have things like the update framework. That's not a Helm chart. You'll have Falsio, Recore, CTlog, which is related to Recore, and then Redis, Trillion, which is a database, which is on, it's a append-only database, which is on top of MySQL. And then people are talking about it. We've got someone at Google saying that it was good. Yeah, that's what it is. The co-creator of Sigstore as well also says it's good. That's also quite nice. And even Wired, I was kind of surprised to see someone from Wired talking about this. They're like a news, they do tech stuff sometimes. But, it's like, oh, that's cool. They're talking about a technical thing. Good for them. And yeah, so first line of defense. Great, I like that quote. Further advice: pin your dependencies. Again, if you know how you entered the place, if you just go out, if you don't pin your dependencies, that's great. Review your dependencies. So get together as in your teams and make sure you know what you got going on, please. Require signed commits. So who cares whatever repository system you're using, you can probably set require signed commits. If you can't do that, switch to something else. And then also, if you have to consume other people's code, which you do, then vendor it. So build it yourself, and then also apply these principles to make sure that it's what you expect. Do automatic updates of your dependencies in a way that you can review. You could use Dependabot Renovate, a thing built in Bash by your friend last week. I don't know. And then you can also deny your software from deny software that you don't want running in production from running, as we've just seen. I'd also like to see offline binary verification. This is used in a few different places. So if you're familiar with how things are notarized on macOS, I'd like that to be standard in Linux production. Let's do that together. I'd like further adoption in open source projects, and I'd also like to hear of more people using SBOMs in all of the ways, because I think who here works for a company that does anything related to development? You should use it. Cool. Yeah. Keep your hand up if you should use it. I didn't really do a good job of the links right now, but the rest of the links are scattered throughout the presentation, which will be available on my site after this. But here's some helpful links. A recap. So software supply chain security is important. I think we've established that. And if we haven't, I have to do the talk again. Sigstore is great for your CI and CD, and it improves your security posture. That's good. SBOMs help you to understand your software, and maybe you might find something out about your software that you didn't know. Oh, I didn't know I was using that dependency. And salsa is a cool form of dance. No, that's not what it says. Also elevates your software dependency, elevates your ability to understand your. Not doing a good job with this. You can read. Gotta Harira, and we have time for questions, maybe, but if we don't, then that's fine. Cool. I'm gonna hand it back and awkwardly flick between these two slides.